So my dear students, in this video we will be talking about engineering cost curves. These engineering cost curves are derived from engineering production functions. These production functions are related to the production which is having a very different type of nature. Here we are having production of very big structures, or heavy engineering work is there, or like construction of big buildings. So these types of activities are actually related to engineering cost curves. Here each production method, okay, let me tell you, there are some limited production methods only, and each production method is divided into sub-activities, and these activities are related to various physical phases of production for a particular commodity. Cost of each phase is calculated on basis of the price. Such calculation is done for all available plant sizes. In engineering production function, there are actually some limited number of methods of production only. So when you see the isoquant, it is having kinked. It is having some kinks. So our isoquant is kinked. It means factor substitution is not continuous but limited. And on kinks of isoquants, substitution of factors occurs. What does it mean? We are having this type of isoquant in case of engineering production function. Suppose there are only 3 methods of production. So substitution between labor and capital is not continuous here. You can see only a limited substitution is available. This is case of limited substitution. If there is continuous substitution, our isoquant is like this. So our isoquant is having kinks. And on the straight segments, so we are having some straight segments also like this. These are straight segments. On these straight segments, actually we are using a combination of 2 different methods of production. And here on this segment again, we are using combination of production method of this and this. So usually we do this. So on straight segments production isoquant, a combination of the adjusted methods of production is employed. In engineering a production function, there is indirect substitution of factors via substitution of process, and each process use factors in fixed ratio. It means for every type of production method, we use some particular input ratio which is fixed. So as I have already shown you, this type of isoquant we use. On P1 method of production, you can see on this straight line, capital labor ratio is same for one method. Then for another method, again capital labor ratio is again constant. We can produce more on same line, so we are using same method. So every time we are using same input ratio. Next, let's talk about short run engineering cost curves. So here you can see that this type of total cost is found. Your total cost is increasing on same rate from this point to this point. Then suddenly there is increase in your total cost by higher rate. Then again it is happening. Then from this point to this point, from x1 to x2, this cost is increasing on a constant rate. It is actually a reserve capacity of this plant. Then after this point, again you can see your total cost is increasing at a higher rate. So this type of total cost curve is found. You can understand it like if you are constructing first floor of the building, then second floor, then a third floor. So every time cost of production is increasing with this kink at a higher rate. So this type of total cost curve is found in case of short run. How to draw our marginal cost here? As you know that marginal cost is slope of total cost. Slope is same from this point to this point of total cost. So our marginal cost is also constant. There is sudden increase in slope of total cost. So there is sudden increase in marginal cost. From this point to this point, slope is same. So marginal cost is also same. Now again, it is increasing at a higher rate now. So you can see this zigzag form of your curve. This is your marginal cost. What is happening to average cost? If you are aware about this method, I guess you are. If we join our origin point with every point of total cost curve, and their slopes are actually average cost. This is one method of finding out the average cost. So average cost is continuously decreasing from this point to this point. Average cost is continuously decreasing. What I am saying here is actually, suppose this is our curve. So from origin point, if I join every point of your total cost to origin, slope of these lines are actually average cost. This method you can use in every type of cost curves like short run normal cost curves, long run cost curves. Even in modern theory also you can use this method. So if we use that method, you will come to know that average cost is continuously decreasing from this point to this point. This is your average cost. Then after this point, it is increasing. Your average cost is increasing. So this zigzag form of curve is your marginal cost curve, and this smooth curve is your average cost curve. You can also draw here average variable cost. This dotted line you can see is your average variable cost. So this is short run cost curve actually. What will happen in long run? If we talk about long run cost curves, I mean engineering cost curve, simply I have removed that portion of our short run cost curve and we assume that our LAC will not increase further. So if you remove this portion of short run cost curve, you will get long run cost curve. So you can see here, this is long run average cost curve and this is long run marginal cost curve. Here is long run total cost curve. So now I think it is clear to you people. Now